This is how easy it is to live off the grid and cut your tether to the electric company. You just need your own solar setup that is easy to connect. It's pretty much mistake proof. As you can see here, we have the Marine battery. It has dual terminals for positive and negative. Putting the smaller one on the small clamp, which is from the solar panels that is charging the battery. And the larger cable coming from the battery goes to the power inverter. This is what changes DC current into AC current so that you can use any type of appliance within the specified amount of power that it gives out. This particular unit can maintain 750 watts of power with a power boost if needed, such as if a refrigerator turns on, up to 1500 in emergency power. So the constant power outlet that you can get out of this inverter is 750 watts safely, but it can provide more. This unit shows the voltage that is going into the battery from the solar panels. And that's 12.5 volts. That's where you basically want it, maybe a little bit higher. You don't want it to go below 12 volts because then it becomes a total dependency on the battery, which is a 12 volt battery. As long as you have more water pressure going into your battery or electric pressure than what is coming out of your battery, then you can maintain your charge. If it goes below 12 and hangs in the area of 11.8, it'll start an alarm and it will let you know that there's a low voltage input and that the system will shut down so that it will not burn out the inverter. The inverter automatically checks this as well. So there's like a little smart chip in here. Right now I've kind of cheated. You're only supposed to have 2 plugs and each of them have covers, but you can't see it that well because it's black. But I put an extender on here because I plugged in both my computer and my monitor. Okay, and since I've done that, I can turn on the computer. I'll turn it on here for you. This is my computer, Genesis. Let me turn on the inverter. That's an important thing for a little green light to be up top there. The inverter has a little fan in the back, and this one has a little chirp to it because it goes on and off. It's like a thermostat. It's only blows the fan as it's needed. It doesn't constantly go all the time. Now we can turn on the computer. Okay. And you'll hear the fan from the inverter kick on and off. And now we'll go up to the computer screen, which is also plugged into the inverter. And you can watch it boot up. Of course, I have a dual booting system here. And everything starts up, holds the power. I can sit here for hours as long as there is a constant power charge into the battery from the solar panels. I can pretty much run it indefinitely. But at nighttime, it depends on how big your battery is and how much storage capacity you have in your battery to maintain your electric power, because it's not charging that time at night because there's no sun, obviously. Now, back to the meter. You saw before it was 12.5. Since I've turned the computer on, the charging voltage going into the battery from the solar panels has dropped to 12.4. So this means that it's just basically using the current straight from the solar panel into the computer, bypassing the actual charge, but we are still maintaining a 12.4. You definitely want to stay above 12, or like I say, the system does tend to get the low power alarm and then shut down a few seconds after that. So at least it just doesn't shut down on you. It gives you a little warning. Here's a little switch coming straight from the charger. It's a light. I'll turn on the DC powered light, and there you can see it lit up. That's not an AC bulb. That will not work in an AC socket. And then we turn it off. So you can maintain a little light, very low power. Sorry about the jiggling around there. Okay, so that's the demonstration of my first solar power setup with everything here that you see. Solar panels are outside on the roof.